Hi everyone. We are going to review the cumulative exam number 5, which is part 3 today. We are staying in home base. I will be back tomorrow, but for today we are going to spend the entire period reviewing part 3 of the cumulative test. So what I need you to take out is your notebook, your calculator, and a writing utensil. While you're taking your things out, you are going to use your notebook. You can write down anything that you want from part 3 of the test, whether it's the question, whether it's the multiple choice, whatever will help you. I do want you to title your page Cumulative Part 3 once you have your paper or notebook out. That way you know that this is part of the information for the Keystone exam, and that you also remember that it's from a cumulative test. So in the future, when we have another one, you will have notes to study from. Part 3 has a box and whisker plot on it, so you will need your calculator for this to help you through that. That's why you need your calculator. As I go through these, I am also going to let you guys and girls know where you could have found these problems in your notebook, what chapter it was from, or when we may have done it in class. Keep in mind that these problems are difficult. It's application of the concepts that we did. You will see problems just like this on the Keystone exam, okay? The harder problems that we do now, the more prepared that you'll be in May when you see the Keystone exam. Any additional questions that you have for me today, please make sure you see me tomorrow so that I can go over it with you, because I will be here tomorrow. Okay, please make sure that you title your notebook or paper Cumulative Test, and then Part 3. Okay, and if you want to put somewhere Keystone Practice, that's fine, so that you remember that these are Keystone Practice problems. So Cumulative Test, Part 3, which is also Keystone Practice. Okay, number 1 says, what is the factored form of x squared plus 2x minus 63? So this is from Chapter 9, your green Chapter 9 packet. We also reviewed this with you guys, Mrs. Warnock did, when she did Keystone Worksheet number 2. So there's 3 terms here. You should first ask yourself, what kind of factoring do I need to do to solve this? So hopefully you guys realize this is an AC grouping problem. So to solve this, you have to do AC grouping to figure out which one of the factors it is, or maybe it's a problem that's not factorable. Maybe there's not an answer, which is what letter D is telling you. So let's go through and do AC grouping and see what we get. So I would make sure you write the problem down in your notebook. The first thing we do for AC grouping is multiply A times C, so we get negative 63. Write down what B is, which is 2. So you need to figure out what 2 numbers multiply to give us negative 63, and at the same time add to give us 2. So hopefully you realize that those factors are negative 7 and 9, because negative 7 times 9 is negative 63. Negative 7 plus 9 is 2. Once you have those terms, you're going to replace them with the middle term on the original problem. So we have x squared minus 7x plus 9x minus 63. Remember, it does not matter the order that you put those 2 terms in the middle. You will still get the same answer. We are now grouping the first 2 terms, grouping the second 2 terms. We're going to take out the GCF. In the first part, the GCF is x. We are left with x minus 7. The second part, the GCF is positive 9. We are left with x minus 7. You then have 2 binomials that are the same. We're going to take the x minus 7, write that once. Take what you're left with in front, which is x plus 9. Write that again. The order that you have these doesn't matter. That is your completely factored answer. You will not solve because it is not set equal to 0. So the x minus 7, x plus 9, which is letter C, that is your answer. It is completely factored. So that should have been a pretty straightforward problem. All you had to do was AC grouping. Okay, and the answer was there. Remember, the order of those binomials never matters. Okay, number 2. This one's a little bit harder. Okay, number 2 says, what expression is equivalent to? And then we have this addition problem right here of polynomials. Okay, equivalent means equal. So we need to figure out whether A, B, C, or D is equal to the problem that they gave us. Okay? First thing that you want to do, and hopefully you guys did this on the quiz, is combine like terms. So we have like terms here because they both have an exponent of a 2. We have like terms here because they both have an exponent of a 1. And then we also have like terms here because they are just coefficients. So let's first take care of adding like terms. 8x squared minus 3x squared is positive 5x squared. Remember, when you add, you do not add exponents. Negative 7x minus 4x is negative 11x. Negative 3 plus 5 is positive 2. So we combine like terms, okay? So now we have a trinomial, okay? It's not set equal to 0. If we look at our answer choices, the only one that looks close to that is A. But if I was at school right now, I would ask you, well, what's different about it? Well, letter A, the 11 is positive, but we got a negative 11. So you can eliminate A. That cannot be the answer. C also doesn't make sense. It's a trinomial still, but it's the wrong numbers. So it can't be C either. So I would also then ask you, how did they get to B and D? So think about that for a second. How would they go from a trinomial to 2 binomials? Okay, hopefully that you're thinking or that you realize that they factored. So we need to factor to get to either B or D, okay? There's 3 terms, so we have to do AC grouping again. So let's see what happens here and see if we get B or D. For AC grouping, we need to multiply A times C, which is 10, and write down what B is, which is negative 11. So we need to find 2 numbers that multiply to give us 10, but at the same time add to give us negative 11. So the only 2 numbers that work are negative 10 and negative 1. Because negative 10 times negative 1 is 10, and negative 10 minus 1 is negative 11. Okay, so we're going to take our original problem and we're going to replace these 2 factors that we found with the middle term. So 5x squared minus 10x minus 1x plus 2. Group the first 2 terms, group the second 2 terms. We're going to take out the GCF. In the first set of parentheses, we're left with x minus 2. The GCF in the second part is negative 1 because the first term's negative, so we are left with x minus 2. Take the binomial that's repeated, which is x minus 2, write it once. Take what you're left with in front, write it again. So completely factored, we get x minus 2 and then 5x minus 1, which is the exact same thing as letter B. So letter B is the answer. This one's tricky because you have to add polynomials first, then you need to realize that it's a factoring problem. You then, in this case, you do AC grouping. Okay, if there's questions on this or one, again, make sure you guys see me tomorrow so I can help you with this. Okay, I'm going to skip number 3 for now. That's a box and whisker plot on the calculator. I know most of you are okay with that, but if there's time, I will come back to number 3. Let's go to 4 because I know this one's hard, or harder, I should say. Okay, number 4, I would write down on your paper what I'm circling. Okay, number 4 says, on a test, a teacher asks the students for a solution that will satisfy the inequality negative 5 less than or equal to negative 3/5 x plus 1 less than 19. 4 of the students' answers are below. So we need to figure out which of the following choices are correct. My recommendation for you is, if you didn't do this on the test Friday, is to solve the inequality here and figure out what students' answers are true. And then we're going to look down here to see whether A, B, C, or D, or E is the answer. So I want you guys to rewrite -5 less than or equal to -3/5 x plus 1 less than 19. Okay, so this is a compound inequality where when you make the graph, it's going to connect in the middle. So x is going to be between two numbers. To solve this, your goal is to get x by itself in the middle. So we first need to clear fractions. Because this fraction has a denominator of 5, we are multiplying everything by 5 first to clear the fraction. So let's clear our fractions. This becomes -25 less than or equal to. These 5's clear, so we have -3x. 5 times 1 is 5, so this is a positive 5, less than 19 times 5 is 95. We want to get x by itself in the middle, and I know I will keep saying that. So we're going to -5 in the middle, left, and right. Don't forget, what you do in the middle, you also have to do on the left and on the right. So I'm going to cross this off. These cancel. So we have -30 less than or equal to -3x less than 90. At this point, you almost have x by itself in the middle. We need to get rid of the -3. Okay, the opposite of multiplication is division. So we are dividing the middle, left, and the right by -3. So I'll ask you guys, what happens when you multiply or divide an inequality by a negative? Hopefully you remember that the inequality sign flips. So -30 divided by -3 is +10. Less than or equal to changes to greater than or equal to. The x stays in the middle by itself. Less than changes to greater than. And 90 divided by -3 is -30. So here's our answer because we have x all by itself in the middle. Let's make a number line just to help us, okay? Remember, -30 is the smaller number, so that should go towards the left. 10 is the bigger number, that should go to the right. You should have a filled-in circle above 10 because there's an equals to with the 10. You should have an open circle above -30. So now you want to figure out which way that your arrows are going to go. X is by itself in the middle, so you know it has to connect in the middle, but let's make sure. So if we read this way first, it says x is greater than -30. So it has to be going this way. If it's greater than -30, it has to be pointing towards the right. If we read this one, it says, and we're going to read it backwards here, x is less than or equal to 10. So if x is less than or equal to 10, it's going this way. It has to be smaller than 10. In other words, x is between -30 and 10, okay? So they wanted you to answer this, but we also have to understand what this really means. Okay, so if x is between -30 and 10, let's look at Adam's answer. So I'm going to go back up here where I'm drawing the star right now. So if you look at, if x equals 5, is Adam right? Can x be 5? Yeah, 5 is about right here. So yes, that works. X can be 5. Bridget said x is 11. 11's over here where I'm drawing this blue line. Okay, that is not correct. Based on our answer, 11 is not between -30 and 10. So it cannot be 11. Cole said x is -15. -15 is about right here. So yes, x can be -15. So Cole is right and Adam is right so far. Dan said x is less than -20. If you look at less than -20, -20 is about right here, but x is less than -20, it keeps going forever and ever and ever. Our answers or our graph stops at -30, and actually it stops at -29.99999 repeating. So Dan cannot be right because all values less than negative 20 are not in our range of negative 30 and 10. Aaron said x is greater than 2, or is greater than or equal to, excuse me, to negative 2. Positive 2 is right here. If Aaron says that x is greater than or equal to 2, and let me use a different color here. That means all solutions will be going on forever and ever and ever and ever. That does not fit in our range of x's between negative 30 and 10, because an answer like 12, 13, 14, 15 could be true for her if she says x is greater than or equal to 2. So Aaron cannot be right. The only two that are correct here are Cole and Adam. Those are the only two that make our range of answers true. X is between 10 and negative 30. So letter B, which says Adam and Cole gave a correct response, is the answer you should have chosen. I wish I was there today to ask you what you think about this one. I think this one definitely can be a little bit confusing with all the wording, but my recommendation to you is to go through and solve it first, just like we did. You get your answer, which is a range of what x is between, and just go through each person, see who is right and who is not. Then look at your A, B, C, D, E choices. Okay, and again, through this video, feel free to pause it if you need to rewrite something again, or if you just want to pause it to ask another student something or the sub something, feel free to do that. All right, let's go to number 5. Okay, number 5, this one should not have been too bad for you, but again, I'm not there to ask you, so I'm not sure of your opinion, but let me read it and then we'll talk through it. 5 says, Emerald opens a business for a one-time cost. This cost is represented by the horizontal line. So his business cost is represented by this line. A horizontal line is just a straight line. Okay, that's the cost. It then says the income that Jake makes from his business is represented by the other graphed line. What does the shaded region mean? And actually, this should say Emerald, not Jake. Wrong name here. Okay, so Emerald's income is represented by this. I'm going to make it blue. Is represented by the blue line. What does the shaded region represent? So we need to figure out the colored in region that's colored in black. What does that mean? So if he opens up a business for a one-time cost, he pays that once. The cost that he's spending is represented by the straight line. The income that he's making is represented by the curvy line, which is the blue line. Okay? The shaded region is telling us that the income, okay, that blue line, is greater than the cost. So this shaded region right here, okay, is telling us that the income, I'm just going to abbreviate, is greater than the business cost. Okay, and you want that to happen. Okay, you want that income to be greater than the business cost. Okay, you want him to be doing well and making a profit for his company. So letter A says, when Emerald's business costs exceed her income. Okay, that's not true because the graph does not show that the business costs are greater than the income. That would mean that the red line would have to be bigger or greater than the blue line. So A cannot work. Okay, the red line is not greater than it. B says, when Emerald's income exceeds her business cost. And remember, the income is what they make from the business. Okay, so B could be true. Let's just read C and D to make sure. C says when Emerald's business costs equal her income. C is not right. If it was equals, the graph would be, I don't know, something like this, where they would meet in one spot, and they would ask you about what that one spot or that 1 point means. So C is not right. It doesn't exactly equal it. so it's not C. D says, when Emerald closes her business, if the income that she's receiving from the business is greater than the costs of the business, that doesn't mean she's going to close her business. So D is not right. Okay, she's not going to close her business if she's making more money than she's spending on the company. So that's a good thing. You want the income that she's getting from the company to be bigger. B is the only one that works, that represents our graph and what we talked about over here. Okay, remember that cost line was the red one. The blue line represented the income. And if you look at this spot right here that I'm circling, blue is greater than red, which means the income is greater than the business cost. Hopefully that makes sense. And again, maybe this is easier than I think it was for you guys. I'm not sure. But use colors if you need to. You will see problems like this on the Keystone exam, where they'll give you graphs. They will ask you to analyze it, to figure out whether something's true or false. Okay. Let's go to, let me see how much time I have left with you guys. Okay, let's go to number 6. Yeah, let's go to number 6. All right, the bean problem, which I know you guys love. Okay, the bean problem says, according to a company that sells beans, there is an average of 360 uncooked beans in 1/4 of a cup. Once the bean is cooked, it will expand to 9 times its uncooked size. How many beans are in 1 cup? The first thing that you want to do is find the number of uncooked beans that are in 1 cup. Okay, so how do you do that? How do you find the amount of uncooked beans in 1 cup? Hopefully you were thinking, or hopefully someone said, you take 360 times 4. You need to take that fraction, multiply by the denominator, figure out how many uncooked beans are in 1 cup. 360 times 4 is 1,440. Okay, step 2. We know once the bean is cooked, it's going to expand 9 times its uncooked size. So we have 1,440 uncooked beans in 1 cup. Well, when they're cooked, they're going to expand. So that's growing. It's going to get bigger. Okay? Because it's expanding, we need to take that number. We need to divide that number by 9 because we need to figure out how many cooked beans are in 1 cup. So we end up finding that there's 160 cooked beans in 1 cup. And that's our answer, which is letter A, that there's 160 cooked beans in 1 cup. We've done this problem a lot, so I am assuming and hoping that this was not too much of a problem for you. The only wording that I want to point out is right here. Sometimes they'll ask you how many cooked beans are in 1 cup. Sometimes they'll ask you how many are in 2 cups, 3 cups. If it was 2 cups right here, you would have to multiply that 160 by 2. So just pay attention and make sure you realize whether they're asking you for 1 cup or 2 cups. Okay, that was the bean problem. Let's go to I think number 7 is a little bit harder too. Yeah, let's go to number 7. Okay, number 7. Yeah, this is the one I like. Okay, 7 says, for an answer, Lamangelo, I think that's how you say his name, answered 4x squared minus 5x plus 6. Which of these expressions is the original problem? So we need to figure out whether A, B, C, or none of them is equal to this original problem. So what do you think the easiest way is to go about this one? Okay, hopefully someone said, or hopefully you thought, go through the answer choices and simplify them. And let's see if we can get any of the answer choices to equal the original problem. Another thing that you could have done first is you could have AC grouped the original problem. So there's 2 ways that you could have started this. Maybe you started it a different way, I'm not sure. But I think for this one, the easiest thing to do is go through A, B, and C, and let's see if any of these are equal. So in letter A, we just need to simplify this expression. There's a negative in front of these parentheses, so we're going to distribute that negative, and we're going to distribute this positive 3. So we have 6x squared, we're just going to rewrite it. Negative 1 times 2x becomes negative 2x. Negative 1 times negative 3 is positive 3. The minus 2x squared gets rewritten. And then positive 3 gets distributed through. So we have minus 3x plus 3. So we just distributed the negative 1 and we distributed the 3. Now we can combine like terms. So I'm going to circle the two terms that have an exponent of a 2, and let's underline the two terms that have an exponent of a 1, and then I'm going to put a box around the terms that are just numbers. Okay, so 6x squared minus 2x squared is 4x squared. Remember, when you're adding, do not add exponents. Negative 2x minus 3x is minus 5x. 3 plus 3 is 6. So for letter A, we get 4x squared minus 5x plus 6. If you look back at the original problem, that is the exact problem. So it kind of worked out nicely. Letter A is the answer. That simplifies to the expression that we had in the original problem. Now, if A was not right, how would you simplify B and C? Okay, hopefully you guys either answered or realized that you would have had to have FOILed both B and C, doing first, outer, inner, last, to see what trinomial they are equal to. But because we already found A is the exact answer, you do not have to do that. On the actual Keystone exam, I recommend that you double check B and C just to make sure you did not make a little mistake on letter A. Okay, let's go to number 9 first, then I'll come back to 8. Okay, number 9, on your paper, I want you to write down this problem. 4x plus 9 greater than 45. Number 9 asks us, what graph represents the solution to the inequality 4x plus 9 greater than 45? So to start this one, we need to take the original problem that they gave us, and we need to solve it. And we need to see what graph is equal to this. So to solve this, we need to subtract 9 on both sides. Remember, solving an inequality is the same way that we solve an equation. All the x's on the left, all the numbers on the right. We get 4x greater than 36, not the 9 that I subtracted by, because 45 minus 9 is 36. Then we're dividing both sides by 4. So we get x is greater than positive 9. So look at your graphs, and you need to figure out, all right, x is greater than 9. On your number line, you'll have a bunch of numbers, you'll have 9 somewhere. Greater than is an open circle, so you know it has to be an open circle. And also, greater than is going to the right, because all the numbers to the right get bigger. So your arrow should be going to the right. There are not any graphs that have an open circle and are also going to the right. A and B are definitely wrong because the circles are not even open. C is wrong because the arrow is going to the left. Okay, remember, you don't flip the inequality sign unless you're multiplying or dividing by a negative. So this one is actually choice letter D. It's none of them, okay, because x greater than 9 is not there. This was in your notes under the solve for x section, where we solve for equations, inequalities, all different types of solving for x, including factoring, which we've done a lot of factoring problems here. So anything where you solve for x, it's in your notes under the title Solve for X. Okay, I'm going to go back to, I think I'm going to do one more. Let's go to number 8. I'm going to go back to that. Let's see how long this one takes us. Okay, number 8, this is also a solve for x problem. If x cubed plus 2x squared minus 25x minus 50 equals 0, then what does x equal? I want you to at least put the original problem in your notebook. And again, hopefully you're taking whatever notes you need to, whatever notes will help you. So we have to solve this. Okay, there's no way we can go through the answer choices and say, all right, we can eliminate this, because we don't know yet what it might be and what it might not be. So we're going to write the original problem here. This one is set equal to 0. So this one's different because not only is it a factoring problem, but it's a factor and solve problem. So we need to factor and solve. There are 4 terms. So your gold paper that you have for solve for x tells you this is a factoring by grouping problem. We are grouping the first 2 terms, we are grouping the last 2 terms, okay, and we're going to go through and we're going to factor. The GCF in the first part is x squared, so you're left with x plus 2. GCF in the second part is negative 25, you're left with x plus 2. Everything is still equal to 0. You're going to take the x plus 2, you are going to write it once. You're going to take the x squared minus 25, you're going to write it again. So the highest exponent is a 3. So right now, as it stands, we do not have 3 binomials. So we know if we split them up right now and set it equal to 0, it's not going to work. We need 3 binomials so that we can take care of getting our 3 answers. Hopefully you guys are ahead of me and realized that this is difference of perfect squares. The x plus 2 we can rewrite. The x squared minus 25, you're going to square root each term. You're going to have 1 plus, 1 minus. The square root of x squared is x, so write that twice. The square root of 25 is 5, so write that twice. Now you can set each of them equal to 0 and solve. When you solve the first part, you're minusing 2 on both sides. So we get x equals negative 2, which is the same thing as negative 2 comma 0. When you minus 5 on this side, we get x equals negative 5, which is the same thing as negative 5 comma 0. And the last one, you are adding 5 to both sides, so we get x equals 5. You should have 3 answers. So right there, I'm going to just look at letter A. Letter A only has 2 answers. It cannot be A. Letter B only has 2 answers. It cannot be B. Letter C only has 2 answers. It cannot be C. Letter D has 3 answers. So let's see if that's right. We need negative 2, negative 5, and 5. What's wrong with D? Okay, hopefully you realize this 2 is what's wrong. That 2 should have been negative. It cannot be D because those are not the right 3 answers. This one is letter E, none of the above, because the answers are not exactly what they should be. So this is a good example of a problem where you need to take your time and make sure that all the answer choices that you need to have are in the multiple choice, okay, and that they are there. All right, let's do one more, which is number 10. Okay, number 10, which of the following numbers is an integer? So I'm going to circle the word integer. Can someone tell us, raise your hand please, what does an integer mean, or what is an integer? Okay, hopefully you remember that an integer is a number that goes from negative infinity to positive infinity. It's all nice numbers, no decimals, okay? If an integer is all nice numbers and no decimals, it cannot be A, because A is a fraction. It cannot be pi. Pi is irrational, just keeps going. And it cannot be C, because C is a decimal. D is the answer here, okay? Negative 10 is the number that's an integer. It's a nice number, it's negative, okay? It's not a decimal, it's not a fraction, and it does not have pi in it. Types of numbers we learned with Keystone worksheet number 3. So you should have all these types of numbers notes in your Keystone worksheet number 3. If your notebook is not organized with Keystone review things, Keystone worksheets. If there's any time right now to do that, please reorganize, or I can help you reorganize tomorrow. Okay, we're getting close to May, and I want you to make sure you have everything in one spot. There is no homework tonight. I will be back tomorrow. If you have questions, or if I went too fast on any of these, I apologize. It's hard to teach whenever I'm not in front of you. See me in homeroom or see me during a study hall. I'd be more than happy to go over one of these in more detail with you. Or that box and whisker plot problem that I skipped, number 3. If you need me to review the calculator steps with you, also see me. I will do that with you. I just didn't want to go over class time with not being there today. So hopefully you did okay. Tomorrow I will let you know where to go when I'm back. So just report to home base tomorrow, sign in, and I will let you guys know where to go. Have a good day.